This is the Mod 2021 stats section of your final review. I think that Mrs. Frenken did a very good job of explaining most of this. I had just a couple I wanted to do with you, but I thought while I was doing it, I'd talk about the rest. Number 75, in order to answer this question, you do need to have this curve. And remember that I require that you show me some work for everything. Don't just write down the answer. Because, the answer would be easy for me here, too. But I want something in writing verifying how you got it. This one, you definitely need some work. Even where it says find the range and you're just subtracting two numbers, I want you to show me the two numbers you're subtracting. And remember, this is talking about population standard deviation. This is the only section that says no explanation needed. Remember that basically categorical is word and numerical is numbers. But sometimes a number can be categorical instead, like C. This is categorical. Because in this case, you could take all those numbers and it wouldn't make any sense to do the average. If they look like numbers, but the average makes no sense, it doesn't help. If somebody asked a whole bunch of people, between 1 and 10, what's your favorite number? And then they averaged them. They took the mean. They added them up and divided by 30 kids. And they said, the average favorite number in this class is 2.37. That does not mean anything, because nobody chose 2.37. That's why, even though it looks like a number, it's categorical. This one, I could live without extra explanation as long as you actually explain these things. Don't just say, the population is everybody. Can't do that. Give me a few more words. I'll accept that one without any major explanation. This one, the ones that I've looked at so far that have been submitted, people are just writing down the word. You need to have something in writing that tells me, how did you know it was systematic? How did you know it was stratified? This one, remember that a line plot is the kind where you make the X's. Somebody turned it in with a box and whisker plot. That is not what that is. So I didn't want to do that. Okay. This one, Mrs. Frenken just wrote down true and false. And I think we need more than that. I'm going to require more than that. And if you're having a hard time, sometimes it's just like, duh, why do I need to write anything down? Mrs. Armstrong still wants you to write something down. So the first thing I'm going to do is I'm going to take this thing. It says tell whether each statement is true or false based on the histogram. And this is talking about the height, and frequency means the number of people who were of that height. And I'm going to just put some numbers on top so I know what's going on here. This says between 59.5 and 61.5, there are two of them. Between 63.5 and 65.5, I have 4, 1, 9, 1, 1, 2, and 2. There's a start. We need to remember that when we're looking at this, that borderline numbers jump up. So if somebody was exactly 65.5 inches tall, they would be over here in this section. Anything up to that, like 65.499999, would be over here. You need to keep that in mind. I'll just write it up here. Borderline numbers. Push to the next box up. Now let's see what they have to ask us about here. Less than 8 people are shorter than 67 inches. So I want to figure out, where are the 67-inch tall people? I can see that in this thing, this borderline is anybody with 67.5 is to the right, but anybody who is 67 would be in this section. We're talking about shorter than 67. Now, I don't know for sure that everybody in that box is shorter than 67. Some of them might be 67 exactly. Some of them might be 67.49 inches. But I still have to be able to answer the question, even though I don't know exactly how many people are smaller. But this says less than 8 people are shorter than 67. So I can say if all of these guys, if these and these and these were all shorter than 67, they have 2 plus 4 plus 1. So that's 7. So I think with A, I can answer true. I know this is true because only 7, 2 plus 4 plus 2 plus 4 plus 1 are less than 67.5. So I know that there can't be 8 that are less than 67. Let's look at choice B. Choice B says, there are an equal number of people who are 74 inches tall and 76 inches tall. Now, let's see where 74-inch tall people are. 74-inch tall people are somewhere in this box. And 76-inch tall people are somewhere in this box. Are there exactly 2 people of each type? We don't know that. There might be 0 people who are exactly 74 inches tall. There might be 2 people who are 76 inches tall. So I have to say that that is false. We would always say false if we can't prove that it's true. True or not guaranteed to be true is false. So I would say false. We don't actually know how many of either height. Okay, let me get rid of those extra marks. And then let's look at C. C says, there are more people between 67.5 and 69.5 than any other height. So who's between 67.5 and 69.5? These guys are. I'd say true, because that bar is the tallest bar. I'm not saying you have to use my words. You have to explain it somehow. Okay, I'm back to looking at D now. I'm going to get rid of any extra marks I had there. D. There were 22 people in this sample. To find the number of people in this sample, I need to do 2 plus 4 plus 1 plus 9 plus 1 plus 1 plus 2 plus 2, 6, 7, let's say 10, 16, 17, 18, 20, 22. I have to say true. But I didn't just say true without showing you how I got the information. Let's look at part E. E said the tallest people in the group were between 67.5 inches and 69.5 inches. That is false. It's a common misconception. There's the highest bar, those are the tallest people. But if we look at these numbers down here, we see there are at least 2 people who are between 75.5 and 77.5. And that is taller than these guys who are under 70 inches. The tallest are the 2 between 75.5 and 77.5 inches. 72 inches is 6 feet, so those are the guys way over 6 feet. Let's look at choice F. F says the shortest person in the sample was 59.5 inches tall. This bar contains people from 59.5 to 61.5. If there is someone 59.5 inches tall, he is the shortest. But just because the bar contains that distance, all those heights, doesn't mean there's anybody who is that height. Maybe both of those people are 61 inches tall. They'd still fit in there, and there would be nobody 59.5 inches tall. I'd have to say false. We only know that the shortest is between 59.5 inches and 61.5 inches. Now, I'm writing this rather inexactly. If I wanted to be more technical, I would be talking about between 59.5 and 61.5, including this, but not including that. But when we're writing a sentence, we'd always say between inclusive and exclusive. We just say that, and then if they asked us to be more mathematically exact, we would have to say this. Okay, I have one more question left to look at on here. I'm looking at G. G says the tallest person in the sample was more than 75 inches tall. Yes, true. I know that because the tallest person is, double letter, is between, oops, just the last section, not this. Between 75.5 and 77.5 inches. I know this is kind of running together, but that's why I did it in different colors, in case they started running together. You'd have an easier way of telling it. Now, I hope that helps, because Mrs. Frenken was talking about those things, but some of you were having a hard time putting that in writing. And even though I didn't say on the Zoom this morning that I was going to do this one, I think I am, at least parts of it. This says the mean age of all the students at EHS was 16.2 years old. So when I set up my curve, I'm writing 16.2 right here at the center. And my standard deviation was 0.7. So to get the next one over, I have to do plus 0.7. And these are getting crowded. So I'm going to write them a little bit sideways. 16.2, and then at plus 1, that means the mean plus 1 standard deviation. So I have to add 0.7, 16.9, and I have to add 0.7, which gives me 17.6, and add 0.7, which gives me 18.3. And then I have to go backwards, and I have to take 16.2 minus 0.7 is 15.5. Minus 0.7 is 14.8. Minus 0.7 is 14.1. Now that I have those numbers in there, let's figure out what we can see. And that's a necessary setup. Even if you didn't draw the curve in, you would probably want to start with that. It's what interval captures 99.7% of all the ages. So let me talk about what I know. 34 and 34. This section right here is 68%. That's from 1 to negative 1. This section right here, from 2 to negative 2, is 95%. This section from here to here, put in the third color, because you know I love my colors, 99.7%. And I'm going to go back for just a minute. This one, same thing here, 68, 95, 99.7. So when this one asked me, what's the probability that a randomly selected variable would fall within 3 standard deviations? They're talking about z numbers from negative 3 to positive 3, which is my 99.7%. Okay, back to where we were. This one asks the question differently, but using the same numbers. What interval captures 99.7% of all the ages? So I'm going to think about from negative 3 to positive 3. And I just talked on the last section about the inequality symbols with the equal marks or no equal marks. And they really don't matter on this kind of problem. They mattered there. They don't matter here. And in this case, that means 14.1 to 18.3. And if I was putting that in words, which when we take a multiple choice final, they usually put it in words, I would say between 14.1, that's their ages, right? And 18.3 years old. And I like to think about whether that's a reasonable answer for the question. Do you think that 99.7% of all the students at EHS are between about 14 and 18? Yeah, that makes sense. Let's look at choice B. B says, what's the probability that a student is older than 17.6? So I'm talking about the student age greater than, because older than means greater than, 17.6. And then, I didn't write this down. It's been a while since we did it, so I will write it again. Remember, those are my Z numbers. Those are my X numbers. So 17.6 is the positive 2. So I'm talking about Z's greater than positive 2. So I'm looking up here, and I really want to know what's greater than, which means what's to the right from my positive 2. Greater than positive 2, I'm looking at this and this. So I'm dealing with 2.35 plus 0.15, which gives me 2.5%. I should circle the answer up there too. Okay. Part C. What's the probability a student is younger than 17.6? So X less than 17.6. Z less than 2. So I'm looking for, this time, everything to the left. So all of those things. There's more than one way to figure that out. But to me, the easiest way to do that is to probably say, I already know that 2.5% of them are more. 100 minus 2.5 tells me that 97.5% or less. But if I didn't happen to have already done part B, I could do this by saying 13.5, 34, add all those guys in there, or just say, wait, that half is 50 plus 50, and I would still get 97.5% for my answer. But if you're already done B, C is much easier to just subtract it from 100 because it's everything else. Let's look at part D. D says, what's the probability that a student is younger than, that means less than, 15.5? So Z less than, sometimes I have to pause my video and get rid of my garbage so I can see the rest of this. 15.5 looks like he's right here at -1. So Z is less than -1. I'm looking for all the percents that are less than -1, which would be those three. (0.15) plus 2.35 plus 13.5. 16%. Okay. Let's look at choice E. E says, what's the probability that the student is 18 years or older? So greater than or equal to 18, which means Z greater than or equal to, and I'm looking for 18 over here, but unfortunately I'm not finding 18 over there. I got 18.3, and if there's no 18 on that curve, you cannot figure it out with just the curve. You're going to instead have to deal with that little formula. Let's put it in the top right corner. We say Z equals the number we want to know about in the problem minus the mean, which is usually marked by X bar, divided by the standard deviation. I can tell just from the curve that it's going to be 2 point something because it's right in here between 17.6 and 18.3. I have to use the formula to figure that one out. Z equals the 18 I want to know about minus the mean, which was 16.2, divided by the standard deviation, which was 0.7. And unless your calculator will show it exactly like that on your screen, you're going to need to throw some parentheses around here so your calculator knows that it needs to do that subtraction before it does the division. All right, 2.571. Our table only takes us 2 places past the decimal. So I'm writing here 2.57. And let's go look at our table for a minute. This is the negative. I need the positive page. But what we need to know is that the table tells us less than. So when I'm thinking about using my table, if they ask me for less than, I can use the table number. If they ask me for greater than, off the edge, sorry, I have to use 1 minus the table number, or I can do 100 minus the percent that I get from the table. And if they tell me that they want between, to do the table number minus the table number, where this is the big one and this is the small one, and P is always this number we're getting from the table. That's what they call that. So let me go back to the problem and see what I'm looking for. 2.57. Those are the negative z's. I need the positive z's. There's my z. I'm looking for the positive z. And I come down here and I see 2.5, but I want 2.57. So I look across the top and I see this 0.07, and I see I'm going to come in from here. I'm going to come down from here. I'm going to find this place where those two meet, 0.9949. But because this is a greater than, not a less than, I'm going to do 1 minus that number. Or you could change it to 99.49 and do 100 minus that, but I generally just do it this way. 0.0051, which when I change it to a percent would be 0.51%. In other words, 0.5%. Again, think about if that makes sense. How many people are 18 years or older? Not very many. 0.5%. Half a person out of every 100. 5 people out of every 1,000. If there's about 3,000 people in the school, that'd be about 15. About 15 people are over 18. Seems like it should be a little higher than that, but hey, maybe this survey was taken near the beginning of the year, and at the beginning of the year, there are very few 18-year-olds. Look back in D and see if it makes sense. D was that what is the probability that the student is younger than 15.5? 68% younger than 15.5. Again, that sounds like an early in the year number, because by the end of the year there are a lot of sophomores who've turned 16, but that looks reasonable. Part F. What's the probability that a student is between 15 and 17? I would think that number is going to be pretty high. Between 15 years old and 17 years old. Let's think about the z's that go with that. Oh, unfortunately, if I look at my curve up here, I'm not seeing 15 or 17 anywhere. That means I'm going to have to do a little z number for each of these. So the z for the 15 looks like this. 15 minus the standard deviation of 16.2, minus the mean of 16.2, divided by the standard deviation of 0.7. And I'm also going to have to do a z for the 17. So 17 minus 16.2 divided by 0.7. Notice that the 15-year-old, his age is below average. He's going to turn out with a negative. The 17-year-old, he's above average. He's going to turn out with a positive. If somehow it doesn't turn out that way, above average turns out to be positive and below average turns out to be negative, you should rethink these things, because some people keep mixing up those two top numbers. I'm going to pause and put both of those in my calculator. Okay, our table goes two places past the decimal. So we're going to keep this one at 1.71. The 4 didn't push it up. And keep this one at positive 1.14. The 2 didn't push it up. I need to look up the two table numbers. And I need to subtract the big table number minus the small table number. But I'm going to write this over here. Negative 1.71 and positive 1.14. And I'm going to look at the table numbers for both of those, the P numbers. This one will have a P equals, and this one will have a P equals. And then I will take the large one minus the small one over here somewhere and finish that. Let's do the negative one first. Negative 1.71. So I have negative 1.71. Negative 1.7 is right here. And I need a 1 on the end, so right here. So I'm going out this way, down this way, picking up this number here, 0.0436. Yeah, don't round those off. Because once we change them to percent, I want them to still have two places past the decimal. The other one is positive 1.14. Positive 1.14. Oh, I lost it already. 1.14. Positive 1.1. Go over to the 4. 1.14. 1.14. Here's the number I need. 0.8729. 0.8729. Okay. Now I need to think about those being subtracted, and I think I'm going to go ahead and change them to percents before I subtract them. The big one becomes 87.29%. The little one becomes 4.36%. And I subtract those two numbers. 82.93%. Okay. Do I have answers for everything? I started this one in purple. Maybe I'll circle this answer in purple to make it clear what's what. Notice that I used the curve when I could, and then I switched over to the table when I couldn't use the curve anymore. If you have the whole curve, if you have the whole table, you could have done every one of those with the table. The answers might have been just a little bit different on B, C, D if you'd used the table instead. I think that 16% using the table turns out to be 15.85. I think 97.5% using the table is 97.72 maybe. And I don't know exactly what we get from 2.5, but I'm thinking 2.28%. So that if your answers are just slightly different because you used the table instead of the curve all the way along, that's still okay. I will know when I'm looking at them that you have the right answers. Maybe I'll go back and put the alternate answers into the answer list on this section as well. I really wanted to go over that one because that's one where I gave the notes in class, but it was rushed on that last Friday before we ended school. And some of us could have used another day of me talking over in class, and you didn't get it. You just got my notes in class really quick, and then Mrs. Frenken's notes, which may or may not have shown every detail that I usually show. So I wanted to make sure I did that. But that's the very last problem on that section. And we worked through this because I know she only wrote true, false, and you would have had to get the rest from her spoken words. These, she did a good job of writing them down. I think that she wrote reasons for that. If you need more help with the reasons for that because she didn't write reasons, call me, email me. I'll look at it again for you if you need to. This one, make sure you have full descriptions, not just a word, and then I won't require any formulas or anything. This one says no explanation needed. This one you definitely have to show me some work for. Okay, I think I'm done with that unless somebody tells me later that they need more.